Okay, so today we'll be learning how to sketch the graph of the gradient function from the graph of the function. We're actually going to call it how to graph the derivative from the graph of the function. So let's say we're given a graph, in this case, a straight line, and this is our f of x. We will be learning how to graph f dash of x simply from looking at graph. So let's redraw this graph over here. 0 to 4 and -4 to 0. And it's supposed to look straight. The way we can draw the derivative is we have to know what the slope is or what the gradient is. So the way we check is go from left to right and see if the graph is increasing or not. Clearly, this graph is always getting bigger. So we know that it's increasing. Now, not only is it increasing, it's increasing forever. There is no other turning points. There is no change in derivative, meaning that the derivative will be positive always, meaning it will be on this side of the graph forever. Since it's a straight line, we can tell that this derivative is the same everywhere. Common way we can check it is rise over run. Now, we have two coordinates, so let's do 4 minus 0 over -4 minus 0. Oh, sorry, 0 minus -4. We end up 4 and 4, which is 1. So the derivative is 1. So f dash of x looks like this. Straight lines are a little less self-explanatory, to be honest. It's easy to explain a parabola, but normally you don't have to do these calculations unless it's a straight line. So let's have a look at another graph. Let's see. Okay. This is our f of x. And we wanted to draw our f dash of x. First thing we want to do is we want to see if it's decreasing, increasing, or stationary. So let's go from left till right. From the left, we can see it's always increasing up until we hit a turning point. And then from that turning point, it'll always decrease. So let's call this point A. We don't know it at the moment. But from the graph, derivative, up from infinity all the way negative infinity, sorry, it'll be an increasing graph. So its derivative will be positive. So even though the derivative is decreasing, it is still negative. Sorry, it is still positive because it's above the x-axis. Now, from A to infinity, it will be decreasing. Now, decreasing means it's below this line, increasing means it's above this line. How will you know which way to go? You always go left to right. Now let's find what A actually is. Using our logic, axis of symmetry, we've got 2 points which have the same y-axis, a y value. So we can tell that A is 2 because 0 plus 4 over 2 equals 4 and 2 equals 2. Let's do this cubic. So it's at -1 and 6 and 5 and -3. And they've given us some turning points, which is very useful. So this is what the axis roughly looks like. If this is f of x, we need to find f dash of x. First, let's start from all the way to the left side and move on to see where the graph is increasing and decreasing. So from infinity, we're increasing all the way until we hit -2 where we're stationary. And then we're decreasing up until 5. And then we're increasing. Now, the first points we want to put on this graph are our turning points. More importantly, the x value. We don't care about the y value, just the x. So -2 and 0. We know this is going to be 0 because that's where the turning point is. So key thing, a turning point on f of x at x equals a means that at x equals a on f dash of x, f dash of a equals 0. So since there's a turning point at x equals -2, at f dash of -2, it has to equal 0. This is, it makes sense when you're doing the calculations, but when you're looking at a graph, sometimes we forget this. So this is very key. So we also have a turning point at x equals 5 and y equals -3 on f of x. That means at f dash of 5, it's equal to 0. Now, let's have a look at where our graph is increasing. Now, before we do that, actually, one thing to note is, in other words, whenever there's a turning point at, let's say, x is equal to -2, the derivative has an x-intercept at that same point. So notice how the turning points end up on the x-intercept of graph, of the derivative. So now we notice from -infinity, so from left to right, our graph is increasing. So if your graph is increasing, that means the derivative is positive, meaning it's up above the x-axis. So it looks like this. Now, from -2 to 5, we know that the graph is decreasing, meaning it's negative. And from 5 onwards, we know that the graph is increasing, meaning it must be positive. Notice how this works. Cool. Now, these other graphs are slightly different because these aren't parabolas. I'll quickly do H to show you how kind of simple it is with polynomials. So that's straight lines, parabolas, cubics, quartics even. And we'll get into the other stuff later. So here's the graph. -3 and 6 turning point, 3 and 2 turning point. Already know. It's going to be an x-intercept at -3. We'll call this f of x. And then there's going to be a 3. We can tell that it's increasing. So it's going to look like this. And we know from -3 to 3, it's going to be decreasing. That means from r -3 to 3, it's going to be decreasing, which is, in other words, negative. And then from 3 onwards, it's increasing. And it's going to look like this. Now, the shape is easy to assume. Basically, if you imagine a quartic, or if you imagine a cubic, the derivative of a cubic will be a parabola. The derivative of a parabola is a straight line, and the derivative of a straight line is another horizontal straight line. Now let's look at f. F is slightly tricky. You may not have covered this in your class this year, but let's roughly do the same technique. We aren't giving any turning points, but we are kind of given how the graph acts. From left to right, it's decreasing, rather decreasing. And then again, it never actually stops. It never has an increasing gradient. Now, we can clearly see that from here, it only decreases a little bit. And then it starts to decrease a lot. And here, we can see that it's decreasing a lot and ends up tapering off. We'll cover this in more detail, but the general gist is see where the graph is increasing. Using green and red and really helps to define this point. But keep having a go. I would avoid G and avoid F as practice, and mainly do the parabolas. Anyways, that will be all. Any questions, just let me know. Thanks.